So welcome, everyone. Good afternoon. So today we have a really, I think, maybe not surprising session, but really, I think, core to what we're trying to do, thinking about scale and achieving SDGs. So what we wanted to share today is thinking through building blocks of achieving the safely managed quality criteria for SDG 6.1 drinking water. And really thinking of that. So what are the building blocks, but also what are the bottlenecks? And thinking of this from source water to achieving safe water and being able to measure that and report at a national level and also eventually global level. So why do we have poor water quality? Well, there's a number of reasons having to do with poor infrastructure, aging infrastructure that allows leaks and contaminants to get through. We have inadequate regulatory frameworks and implementation of that regulation to be able to achieve water quality criteria. We also face limited use of water treatment technology, limited scale of that technology, and testing and reporting, and low levels of capacity for water quality monitoring, surveillance, and reporting those data up to national and global levels. So what this results in is of course, the microbial contamination, the fecal contamination. We're seeing a lot more challenges with chemical and toxin contamination of drinking water supplies, which are very concerning. But when it comes to SDG 6.1, we're really talking about, at the global level, the fecal contamination and what the JMP refers to as the priority chemical contaminants being fluoride and arsenic. So this is what the data look like now in terms of which countries are able to report on safely managed drinking water. And as of 2022, 73 countries do not report on water quality as part of SDG 6.1. And so that's where you see a lot of the missing data here. And in fact, the drinking water is the most common limiting factor for reporting on SDG 6.1. And also what the JMP reports is that much of the data on water quality for high-income countries is coming from administrative data. So routine reporting of water quality is feeding into these figures. But when it comes to low and middle income countries, the dominant source of data are household surveys, which we know, first, many of them aren't adopting the water quality module, but also this is not a routine source of data and information to be able to report. So these gaps really underscore the challenges that many countries are facing in establishing water quality monitoring and surveillance systems, reporting systems, and speak to the need to really strengthen those systems. So again, getting back to what we are hoping to talk through today are some of those bottlenecks to achieving this standard of water quality surveillance and reporting. So I already talked about this, and just as a reminder, what the water quality indicator is for SDG 6.1. We will focus on that mainly today, even though there's many other issues with water quality contamination. So we are going to go through a series of hopefully quick, I call them lightning talks, but not very, I don't expect everyone to use that format, but we want to get through a number of presentations in sort of a rapid manner that will speak to these four bottlenecks. So one, on regulation, what are the regulatory frameworks? How have they been implemented over time? to be able to achieve water quality criteria? What are the bottlenecks to effective surveillance systems and data management, particularly doing this at scale and in low resource settings? Thirdly, the issues that we have with source water and the poor quality of that water leading to, increased cost and to achieve the water quality of drinking water. And then finally, speaking to bottlenecks around risk management and communication. And I'll introduce the speakers for each of these as they come up. Then what we're going to do is we'll have a bit of time for questions from the audience and a bit of a panel discussion with those speakers. Then we will turn it back to you. And the idea is that we'll have small group discussion. And so you will, hopefully you've sat by people that you want to talk to, because you will be asked to get together in small groups to talk through some of these bottlenecks. And we're hoping that this can sort of generate some ideas and more commentary than sort of the, typical back and forth panel. And then we'll bring everybody back, and hopefully that will be an opportunity for you to share what came up out of those discussions and can help to contribute to the dialogue. So the idea is really, we're going to share some examples of what our stakeholders are seeing in the countries. But we'd like your feedback and sort of, open dialogue about how to do this better and what are the bottlenecks. So with that, and I'll ask each of the presenters when you do your presentation just to come up, and then when you're done to sit at the table so we can have that first segment of the panel discussion. So we are going to start with engineer Robert Gakobia. Robert is an independent wash professional, but I think well known as the regulator for the CEO of the Kenya Water Services Regulatory Board for 13 years. So we're very eager to hear your experience on regulation of water quality. And you don't have a presentation okay, so please.
Thank you very much, Claire. I'm supposed to talk about some bottleneck. And that bottleneck is about regulation in terms of ensuring safe water for everyone. And for us, I think it's about standards, meeting those standards, enforcing them, monitoring them, and enforcing them. But from where I used to sit as a regulator, I think the regulator understood very well that it's very good to have standards. It's very good to monitor them. It's very good to enforce, but it's also perhaps more important to have resources that can actually put corrective action. So that is a kind of double challenge, because first of all, you have challenges in having resources for regulation, and then you have challenges for having resources for performance improvements. But nonetheless, work had to be done, because how we try to make sure that you get safe water in our context is basically by using water quality as one of the indicators and trying to set up some targets or some targets where we would want to be in terms of safely managed water. Now, this work was actually, it gained a lot of traction after our constitution itself said that every citizen is entitled to safe and clean water. So as a regulator, you have to really be ahead in terms of thinking. Policy has to define what is safe. So for us, we thought perhaps safe is safe is trying to meet the standards that have been given either by the World Health Organization or the country standards if they are there. And if they are not there, then you use the World Health Organization standards. And the two indicators that we decided to start already monitoring is water quality in terms of presence or absence of E. coli, and water quality in terms of how much residual chlorine is in the water, to guard against maybe post-supply contamination within the distribution system, and also it is making sure that you are getting out a product that is free from any contamination. But then, when you put that in the context of what the Constitution requires, then you ask yourself, how does it help to just test the sample and just discover that it is poor quality? It has already perhaps impacted on people's health. So how do you try to prevent that? And that is where now we were guided by many of you may remember the Bond framework that brought in this issue of water safety planning and all that. And we started thinking about water safety planning. Around the same time, before even our Constitution, I think we even had WHO already trying to kind of conduct some trainings on water safety planning and all that. I remember attending one of the trainings as a trainee in one of the times WHO were training, and I thought it's a very good idea. In fact, it mitigates against now always acting after the fact. You try to act before the fact, because that way then you are able to protect water resources from the source to the tap. So guided by that, we actually prepared a guideline for water safety planning. We released it in 2019, I think I'm correct in the year that was released, and it became a license condition. If I'm going to license water service provision, one of the license conditions are to be the provider has to prepare a water safety plan for their area. And that now becomes part of the third sub-indicator for water quality. The other one is to make sure that because it is about the source, you also want to know that your raw water is protected, because without raw water, then you won't have safe water. So we also wanted them to actually adhere or prepare from catchment management practices, to have better or good catchment management practices to protect their water resources. Now, but then implementing this, then the regulator has to have capacity. So we also realized that even in our own internal capacity, we needed to boost it up. But also in terms of other regulatory guidelines to guard against the water safety, water contamination within distribution systems, how do these providers then manage their own assets? So we started thinking about water asset development guidelines and water management development guidelines. I'm happy to report that 2 years after my retirement, I think they released the water asset development guidelines, I think sometime last year, or if I'm not, I think mid this year. They released actually those water asset development planning guidelines. And then now they are already embarking on water asset management guidelines to guide the providers how they need to manage their assets in terms of making sure that they prevent or they reduce the risks of contamination. So these are some of the things we have done, but we also realize we need to boost the internal capacity. So we have boosted the regulator has boosted their own monitoring and enforcement capacity. And this requires skills within the regulator, and they have actually hired quite a number of people for that kind of activity. And that doesn't mean that they have what they need. I think they are still challenged in terms of the resources. So the resources is one very big challenge for regulation. But for us, I think we were also lucky because we had our own independent source of revenue in terms of license fees for the providers. So we are able now to collect money from the providers, but that money is also, even if it is there provided, it is still a lot under pressure. Because I've said this many times, I think almost everywhere I talk, the regulator does not have the luxury of imagining that they can only their money is their money. Some people feel that money is not being spent well. How do you spend money by running around telling people to reduce non-revenue water and all that? So they are still under pressure because these are political entities. I mean, are public entities, so they are subject to all the political pressures and all that. But I think we have been able to stand firm and make sure that we have these resources protected. And we are also allowed to do it in our tariffs. And the tariffs also are allowed to do what we call tariff indexation. So depending on the inflation, they're able to adjust their tariffs, but be very clear on what that tariff is funding. If possible, even try to ring-fence some of these resources. That is our experience in terms of making sure that there is safe water from source to tap. Thank you very much.
Thank you, Robert. That was excellent and really touch on all of the issues that I hope we can reflect in the other presentations. You mentioned the legal framework, the standards and guidelines for the testing, water source protection, asset management, really all key. So it's great to have your experience and learning from Kenya. So now I'm going to turn to Dr. Sarah Marks. So Dr. Marks leads the water supply and treatment group in the department SANDEC at AWAG. And she's going to be talking about water quality testing in rural areas, strengthening capacity in rural areas for water quality testing.
Super. Okay. Hi, everyone. It's so great to join a whole series of speakers all on this topic. I appreciate this invitation. Today, I will highlight a long-term initiative that's been ongoing with Helvetis Nepal. I'm not sure if Madden is in the audience, but my collaborator is here. And I'm happy to share about 10 years of collaboration around water quality, also supported by generous grants by SDC in Switzerland and FCDO in the UK through the REACH program. So I thought for this style format, very short talks, a picture speaks 1,000 words. So I wanted to share some of the initial bottlenecks that are really like the everyday experience in this setting. So this is a source in the hilly region of Nepal, which these are not hills as we typically maybe think of them, but at the foothill of the Himalaya, this is the reality, is reaching a spring source requires quite some effort, first for protecting the source, but also if one may want to initially assess the source to understand any quality issues, the investment in that single sample can be significant. Then thinking about where the households are themselves, the distance between households in this particular service area is not particularly long, on a map, but you can see accessing, one tap and then walking to the other. It must be done on foot, and it can take quite some time and effort. So this has real implications if we're thinking about SDG 6 and water quality at the point of consumption. It really does require going to homes. And additionally, there is this policy initiative in Nepal to deliver 1 tap per home, and this includes settings like this. So supply chains issue in many, many places, particularly in Nepal, we see that there's growing momentum around water quality. Supplies are generally available in capital or regional centers, but one very tricky issue that I don't see many people talk about is procuring supplies in a rhythm that allows for water quality materials to be stocked in the right amount to support the tests that need to be done, but not too much that they expire on the shelf, can have big implications for budgets. So it's been a fine balance to really strike that. And I'm excited about some initiatives I've seen on novel media options that can be shelf stable for longer and also at variable temperature. Another bottleneck is just the technical skill. Learning water quality testing takes time. It also takes practice to get to know the test. And what we find is that the initial training and testing is actually no problem, but maintaining the institutional knowledge in place can be a big challenge. So making sure once the protocol is in place and the tests are happening, we have to transfer that knowledge a bit more broadly than just the technician herself. And that means that we can keep consistency as there's staff turnover. So with all of this in mind, the question is, what does it take to implement water quality monitoring testing in this context, and most importantly, at scale? Because one-off testing is one thing. We can all kind of take a handheld kit and maybe have a look initially, but surveillance really requires a system that's operating over time and across space. So that's what really interests me. And I'm happy to share, this feels like a real success after many years of collaboration. You see here the 5 districts where the labs are operating. The laboratories are shown by the red dots. And this is really what a laboratory looks like. It's extremely fit for purpose. It's the basics to get the basics done. So we're looking at basic microbial indicators, pH, temperature, turbidity, and free residual chlorine. So when we began, the collaboration actually began in 2014, but it took a few years to get 3 laboratories in place, which served about 3,000 people. Then in 2019, we began our collaboration with the REACH program. We were able to expand to about 8,000 households. In 2022, there was a big push. This was in large part driven by the SDGs. Momentum began to build around microbial metrics as well as others. And so our catchment grew to 60,000. And what's interesting, what I want to share with you today, is this monitoring program has sort of taken on a mind of its own. So we say when a good idea catches on, the laboratory process and setup has been transferred enough to enough people that now municipal government offices have kind of adopted the approach. And we don't have a very good handle of how many monitoring programs are operating, but they are pretty well harmonized with what we are doing. So you can read about this diffusion of laboratory innovation in A Story of Change, which is on the REACH website. Okay, so only 2 minutes to go, but I wanted to share some of the key ingredients. I don't think this is comprehensive, but just to get you thinking about what does it take to kind of see this scale up. So first, technology is great. Many of us are engineers in the room, I think, and I'm a big fan of technology myself, but technology really needs to be adapted to place. So the incubator, as an example, we found that standard commercial incubators were either too heavy, too expensive, or required too much power. Another drawback of standard incubators is the volume didn't always match the frequency of sampling that we needed. So we wanted to look at if a basic electrical core could work with sort of a range of shell options. So I can't go into detail, but just to show, we've done some interesting student projects looking at the boundary conditions in terms of power consumption, ambient temperature fluctuations, and really arrived at a few configurations that work well. Integrated training is also something I wanted to highlight. Training is expensive. Investment in social costs is expensive. But training is critical. So we have found success merging water quality training with other initiatives such as health campaigns, and things that are basically happening within the WASH sector, even outside, to bring water quality to a broader conversation. This saves resources, it brings more people to the table. And in the photo here, we even had some water ministry officials attending. So it was a big eye-opener for them to see the realities of water quality monitoring in rural zones. So I have just 2 more ingredients. I'll go through them quick. One is aligning local and national water quality metrics. I think this will be familiar to many of you that we really need to be measuring the same things in the same way if we hope to integrate across different scales. So our monitoring is really geared towards operational management, but with links to surveillance systems. In Nepal, this is the NWASH platform. And so we make sure those data eventually get integrated through a free platform. Kobo Toolbox translates it on up to national scale. Lastly, I just wanted to highlight a key theme. I see WHO is in the room, and I really appreciate this new guidelines for drinking water quality for small supplies encourages a culture of learning and iterative improvement. This is key. I mean, key. You have to start somewhere. Sometimes it's extremely difficult to cover everything all at once. It can be paralyzing. So through this program, we've really encouraged to take the first step. Maybe it's just taking a look at turbidity. And from there, it sort of builds on its own because the learning component motivates. So that's all. Thank you.
Thank you, Dr. Marks. That's fascinating. And I really like, because I was a little bit concerned, we keep talking about the bottlenecks, but you brought it to the enablers, which I think is what we want to eventually talk about. So that's fantastic. So now we have one of our presenters is joining us from Karnataka, India. Shri Jafar Sharif Sutar is the Deputy Secretary of the Rural Drinking Water and Sanitation Department in Karnataka, India. And I have been following the work of the water quality monitoring and surveillance that has been taking place in Karnataka, supported through a World Bank investment, results-based investment. So very excited to hear from Jafar Sharif and tell us about the work, the great work that's happening in Karnataka. So I will move your slides. Let me just I'm going to bring you over to the screen so people can see you. That works. I don't know if the IT can help me with that, but I'll go ahead and move forward. Over to you.
Yes. Thank you very much. Thank you very much for this consideration. Namaste from India. This is Jafar Sharif, working as the Deputy Secretary in Rural Drinking Water and Sanitation Department of Karnataka in India. I hope am I audible?
Yes.
Yeah.
Yes, we can hear you.
Yes. Towards the goal of SDG 6.1, the department is working on the water quality monitoring and surveillance system. With respect to the strategic development areas on which the department is working is, can we move to the next slide, please? Yeah, thank you. These are the strategic developed areas where department is working, and we are primarily focused on the laboratory infrastructure. We are trying to upgrade the infrastructure of the laboratories where it's from state level to the village levels. District levels, we have 28 labs which have been enabled accredited labs till now. And next, we focused on the training and development, especially the training the rural population with respect to the water quality assessment, towards the safe and secure drinking water what they are using. And next we have focused on the special drive with respect to the number of testings. Earlier there are very less number of testing used to be happened there, and we have focused more on the testing of using more number of tests in the rural areas. Next, after improving that, we move towards the modernization of the water quality and surveillance, because the dissemination of the results of the tested water to the end users was the most important factor. On that also the department has worked a lot. And next, coming to the chlorination part, because the microbial contamination and on other factors, the department is working on the chlorination aspects also. And finally, by addressing all these 5 issues, we have worked on the water quality grievances redressal system also. People used to raise their grievances in the redressal portal. Next slide, please. Yes, these are, as I told you earlier, since from the state level up till the rural population, we have worked on the infrastructure development and training and capacity building, and also the number of tests have been conducted a lot. And then the ultimate goal was to the multi-tiered surveillance, which ensures the comprehensive coverage and faster response times to contamination issues. That was the fundamental aim the department wanted to achieve. Next slide. Yes, this is about the field test kits where we are using over the period of 4 years what the department has achieved. Because usually earlier there were no much tests used to be conducted there. In the last financial year, we have conducted around 4 lakh, 6 lakh, more than 6 lakhs FTK tests. In the present year, the department has conducted more than 4,46,000 FTK tests as of now, and that is in another still 6 months are remaining. This year, the department is targeting to achieve more than 15 lakhs tests in the field itself. Next. Yes, this is the Jal Jeevan mission is the one of the Government of India is the most important project on water quality, which is especially working on to meet the goals of SDG 6.1 to provide the safe and reliable water to the each and every households in the rural areas. Here earlier before JJM there was no much focus on the water quality, and here in Kobo app, which is the third party toolbox which are used for collection of the samples, where we used to know about the positions of the geolocated positions of the water sample collectors. Here what happens is this map is showing about the how the department has found the gap, what was happening in the field, because whatever the sample collected which was depicted on the Kobo app, by putting it on a GIS layer, we came to know that there was some gaps were found. Next slide, please. Yes, this is the Karnataka map. The differential maps between 2022 and 22-23 and 23-24 clearly shown us that the sample whatever the sample collects earlier, there was no proper and comprehensive approach to collect the samples, due to which there was a huge gap between the coverage of the sample collection. Whole area need not to be covered completely to collect the samples. Whatever the data is collected in the Kobo app, when you put on the natural resource data management system on the geo positions, we came to know that there was the huge gap between the sample collection in the field. After that, this because of the World Bank assisted program, that is Karnataka Sustainable Rural Water Supply Program, which focuses on the one of the DLI was focusing on the modernization of the water quality, by which we came to know that to address these gaps, we can use the technology to bring it on a proper module, that is Jiva Jala, the water quality mobile application, which means Jiva Jala. Jiva means life, Jala means water. Here we are treating the water as the life, life for all. On that aspect, we are focusing on the water sample collection. In this app, next slide, please. Can you move to next slide, please?
Sorry, I'm trying. There we go.
Yeah, here in this app, we are focusing on the geofencing and geotagging of the samples, because of which we can complete the asset mapping also, and whatever the water resources and testing laboratories are, all those laboratories and water sources are getting geotagged in this particular app, and where the water sample collector, when goes to the field, he can update the data whatever the collects in the sample in the field. When he update the sample, submit the sample collected details there, automatically that will fetch into the portal which is being used in the laboratories, departmental laboratories, by which if we can start testing the collected sample there, and we can give the result in the QR code system to the end users also. Next slide, please. And this is our mobile app, what the department is going to launch. In 4 districts, we have completed already pilot studies. And because of this modernization in the water quality, and which is the, as I told you earlier, one of the DLI of the World Bank project, here we are going to, 18 parameters being checked here, and that the result will be disseminated to the end users, like the village water and sanitation committee, and also the Gram Panchayats. Next. And this is one of the important aspect which the department is focusing now, that is about the chlorination of the units. The department is evaluating all possible technologies to establish the chlorination, because in rural areas it was not a practice at all. Now the department is including all the chlorination component as one of the component of the estimations also. And in future, department is focusing to install chlorination unit in almost all the areas. Next. And as environmental safeguard measures, the OST survey has been done in each and every household, and by using a simple Google Forms, because earlier the department has no proper evaluation of the OSTs or overhead tanks. By this we came to know that there are gaps with respect to the overhead tanks, where during this Swachh Bharat Abhiyan, department has conducted the cleaning campaign in each and every households in the state. Next. And this is the most important aspect, because whatever the grievances are with respect to water qualities, and the people used to rise in the local level only by bringing it by using the technology, and which is called IPGRS system. Because of this, we can the people can raise their issues, and the department is working on the focusing on the solving of these issues there. Next slide, please. These are the key takeaways from my presentation today. Because of the innovative methods like water quality management, we are focusing on the decentralized capacity building, especially the village water and sanitation committees, and effective surveillance is being happened. Once the FTK test is being conducted in the field, then which is the presumptive testing. Once the presumptive testing is found contamination there, that sample will be referred to the taluka and district labs, where we can recheck again, and we'll get the confirmation test there. And the large scale water testing campaigns have been done, which is through FTKs only, and the mitigating by which we can nearly mitigating the risks also. The multi-tier surveillance ensures the comprehensive monitoring from state to village levels also. And finally, the introduction of the digital tools, which is bringing the revolutions in the real-time water quality monitoring system in the state. Yes, thank you. This is all from my side. Thank you. Thank you very much.
Thank you so much, Stefan. Really excellent work that is happening there in Karnataka. And I really also appreciate this introduction of the digital tools and how that can also help to scale and increase transparency of the reporting and engagement with citizens. So fantastic. So
Thank
now
you.
we're going to take a step back in the water cycle and look more at the source water. As we mentioned, that's also an important aspect of our drinking water quality. First, we will hear from Carmen Yi. Carmen is a lead water specialist at the World Bank with 25 years experience in the water and environment sectors. And Carmen is leading work on the Ganga Basin on source water quality. So Carmen, over to you.
Thank you, Claire. Can you hear me okay?
Yes, we can hear you.
Okay, so good afternoon, everyone. Thank you for inviting me to speak today about the critical issues of water quality and the ambitious effort underway in India's Ganga Basin. Maybe if you can go to the next slide. Okay, so this region is spanning 11 states and a quarter of India's landmass, is home to over 40% of the population and 2/3 of the country's port. The Ganga River, revered by Hindus as a living goddess, provides over 1/3 of India's surface water and supports 40% of the country's GDP. However, despite this importance, the Ganga faces immense pressure, widespread obstruction for irrigation, industry, and domestic use, coupled with the discharge of untreated sewage and industrial waste, threatens both the river water quality and also key habitat species. If you can go to next slide. Next, so in response to this, the government of India launched the Namami Gange program in 2015, allocating about $4.5 billion over 2 phases through 2026. This ambitious initiative takes a comprehensive approach, basically focusing on pollution control, river ecology, public engagement, research, and sustainable economy development. Next slide. The national, yeah, perfect. The National Mission for Clean Ganga, which is the government implementing agency, has actually made remarkable progress in three key areas, with the World Bank as a supporting partner. First, it has developed wastewater infrastructure in 122 towns, preventing about 3,200 million liters per day of untreated wastewater from entering the Ganga. This actually include wastewater treatment plants, sewer networks and connections, and interceptors. Second, it has also implemented a river basin management principle, which actually includes the creation of river basin units, the drafting of a river basin plans, and also adoption and monitoring of environmental flows in key river stretches. This is an important aspect given that the Namame Ganga program is going beyond infrastructure and including a river basin management principles to have a more holistic approach. And the third point is a robust water quality monitoring system that they have been establishing basically at two levels. One at the STP or sewage treatment plants with online monitoring stations to ensure compliance with effluent standards. And then the second level is basically installing manual and real-time water quality stations at different points, strategic places in the river. Some of them actually situated upstream of water supply and irrigation diversion structures. The Central Pollution Control Board collects, monitors, and transparently publishes this information or this data, empowering stakeholders and the public to track progress. So the results have been promising with improved water quality increase. We have an increased dissolved oxygen. We also have seen reduced microbial contaminants and even the return of habitats like the gangetic dolphins. So the building block of this program, which include the infrastructure investments, river basin management, and water quality monitoring, are crucial for ensuring safely managed drinking water. By protecting the source, we actually reduce the capital and operational costs of drinking water systems, and we also ensure their long-term resilience and sustainability of the drinking water services that provide to the population. Thank you.
Thank you, Carmen. And I think these types of investments at the source level, we need to see much more integration with the water supply sanitation sort of utility side. And our next speaker, Liz Jordan. So Liz is Chief of Party of the USAID Urban Wash Project, and she's going to be talking about engaging utilities in source water protection.
Great, thank you. So as Claire mentioned, I'm the Chief of Party of the Urban Wash Project, which is a part of USAID's Global Water Strategy Action Research Initiative. And we're studying a number of different topics related to how we can better expand and improve urban water supply and sanitation. And one of our particular areas of focus is on understanding what are the drivers to investment in source water protection and what are the barriers that utilities and cities are facing. And so to motivate this, I think everyone has seen various versions of water security threat maps, and we can see that there are a lot of threats out there to both water quality and water quantity, which really affects the urban water supply. And I think we don't always think about the connection between those urban water services and what's happening upstream. But cities, the vast majority of cities are actually at risk from water quality threats. And these are growing. So it's a variety of factors. It's population growth and urbanization itself causing risks to water quality, but also expansion of industrial activities and agricultural activities. And then all of this is, of course, compounded by climate change. And there are solutions that we know about. And so source water protection very broadly are activities that you can do at the source to reduce water contamination in the catchment. And this is really that first step in the from source to tap part of water safety planning. I think a lot of times people think of these nature-based solutions when they think of source water protection. So things like conservation activities, reforestation, or maybe behavior change types of programs like getting communities to adopt green agricultural practices. But there's a lot of options when it comes to source water protection. So the regulatory piece of it, going back to that, that first bottleneck, can be a solution. Land use policies, zoning, permitting, all of that feeds into source water protection. And then there are other options, including some of the sort of classic gray infrastructure that many of us work on. Some of those wastewater interventions that we saw in the last presentation are a part of source water protection. And there's some newer ideas out there like utilities purchasing land to just conserve it. So that's what New York City did. They bought a big chunk of their watershed so that they could ensure it wasn't going to be under threat. So these are out there. We know that they can be effective to solving some of these challenges, but why aren't they more widespread if we know all that? And what we found on Urban Wash through a series of case studies is utilities are often focusing on some core problems that they're facing related to expanding services, trying to hit that, everyone with piped water access, and improving their performance before they start thinking about these longer term risks. And this is particularly true in low and middle income countries where utilities are dealing with high levels of non-revenue water, huge informal settlements that aren't yet connected to the piped water network. And part of that is because source water protection is a long, slow process. You can treat your water right away and see a water quality improvement, but conserving the upstream watershed, it's going to take a while before you start to see those effects. And so it requires that sort of long-term commitment. The benefits can also be difficult to quantify and to measure. There's certainly a lot of ways to model what effect these conservation activities would have, but there's uncertainty in those, and the actual data collection and analysis to go back and sort of retroactively see what happened is expensive. And so that's another cost that utilities would have to face. There's also the fact that there's a lot of coordination involved. When you start to get into water resource management, you're starting to move beyond just working with the utility, maybe the municipal government, and you're starting to deal with basin organizations, potentially a whole different ministry, depending on what country you're working in. And then you also have to think about the upstream communities. So the landowners who would be affected by the activities happening upstream are not the people who are actually benefiting from the improved utility water services. And so that can be a challenge because you have to ensure that you're not, creating any upstream harms to have those downstream benefits. And so one of the really promising solutions out there are payment for ecosystem services mechanisms, which is a way of having the downstream beneficiaries of source water protection activities pay some form of compensation, could be in cash or in kind or other projects, to those upstream communities who would then take on some action or allow for some sort of project that protects the source water. And we have found that there are countries where this has really scaled up. One of the places we're doing further research is in Peru, which has, a really phenomenal national regulatory commitment to payment for ecosystem services, and the leadership and political commitment to keep building on that. And so in that case, there's actually a requirement that utilities set aside a small proportion of the tariff to pay for source water protection activities. But even with that sort of regulatory push and some of the commitment from the utilities, it still requires a lot of work in engaging with the upstream communities. And it's really taken off gradually as there have been example projects and benefits for people to look at and to replicate. It's not a given that it will always work. There are challenges, including some opportunity costs at the upstream level. Those communities, if they can't take part in certain industrial or agricultural activities, are going to face that cost. And there can be issues around who has land tenure and can therefore get a payment through one of these systems. There can be unequal access to payments or a perceived unequal access to payment, which can cause conflicts and really cause these programs to break down. So our future research is looking more at sort of what drives the success of these. So when you do look at a place like Peru that has that regulatory commitment, what enables some utilities to succeed and what barriers are others still facing? And that's where we're sort of going next with this work.
Thank you so much, Liz. And I know there's must be many questions because these are very quick presentations, but really fantastic. And this concept of as you mentioned, the community engagement and driving the incentives, I think would be interesting to bring up in our plenary. So lastly, we're going to hear from Bruce Gordon. And Bruce, I don't think needs any introduction. You've been introduced many times already in the conference, but Chief of WASH at
And I want to be elegant in standing here because you've been so elegant when you thank people, and this is an amazing session. And so thank you, Claire and the World Bank, for convening us all together. And it's wonderful to hear about water safety planning and so many other things. But I'm going to talk a little bit about this risk management and public communication and kind of the nexus in between. And first off, a little bit about what are we seeing at WHO primarily driving some of this concern? What are people worried about in drinking water? And the first thing I think I'd like to reflect on is that none of the SDG criteria that you mentioned, Claire, so the E. coli, the arsenic, fluoride, the priority contaminants, are what is really kind of worrying people. And it's not so much that these things shouldn't be worrying people. They're emerging contaminants and there's some unknowns, but it's just that we need to be able to have our risk assessment and the risk management speak to people with, what the real public health burden really is. So I think there was some comments from our colleague from India about water grievances and consumer satisfaction. That's a key part of water safety, is keeping people happy. So we need to communicate with people, and we need to make sure that our risk management is communicated in a way that makes sense to consumers. So we've had a lot of experience at WHO in terms of some of the risk communication around outbreaks, and it'll be no surprise, I think, to some of you that the movement isn't to kind of sweep things under the carpet. And we've had examples from some countries where there have been exceedances, and the government has been very worried about how the public will react to this. And there has been a little bit of, I would say, potentially paralysis, because, what is the public going to think when they perceive themselves as sort of being poisoned? But when they understand this in the context of a credible risk assessment and corrective measures being put in place through a water safety plan, I would like to think it becomes a lot better. Now, the other thing about public communication is when we think about some of the experts on this, I think immediately of the countries like Singapore or Australia, or countries where they're trying to put in place reuse or have put in place successfully reuse regimes where people are drinking water that's been treated and, coming from eventually or from wastewater. And, there has been a tremendous amount of research and design that goes into these programs, to the extent where if you visit, you'll end up drinking something called new water, and and be satisfied because you understand that the management in place is meeting requirements. At the same time, water projects that have costed millions of dollars have failed because there have been failure to communicate with the public. So water safety plans now, I think a number of speakers have already spoken. Sarah, you mentioned it. Robert, you mentioned it. Last week you mentioned it as well. And so thank you for mentioning it. So I feel like I don't need to really go so much into the principles of water safety plans, but I think just to say that, I mean, there's a complexity to water safety plans, and then there's a simplicity to water safety plans. And the simplicity is simply that you just go from the system, from source, and all those things you mentioned about source water protection are so interesting to me. because I feel like that's been a key bottleneck. I couldn't agree more. And for all the reasons that have been discussed, you know, there's different sectors that are influencing the catchment. There's pollution coming. There's users upstream, and it's really been tough. And when I've spoken to water utilities or those regulating them, they find that very difficult to deal with. So it's great that we're dealing with that. But then all the way through to the household, and trying to do things in a simple way. And the simplest expression is sanitary inspections, which you can see have been around for decades, but are not in many ways very similar in philosophy to a water safety plan. So, you know, I see Rick at the back of the room. I'm going to pick on Rick for a second, but Rick has been responsible in the joint monitoring program for integrating water quality monitoring and the SDG monitoring, which is no mean feat because it's essentially water quality testing integrated within household surveys. And I always thought this is going to be incredible, because imagine once we have the water quality data from the country, and you mentioned those, Claire, then what is the response going to be? Because it's not going to be about ribbon cutting and infrastructure. It has to be some sort of massive scale up of water safety planning and management approaches, which isn't as sexy, or sorry, that's probably not the right word nowadays, but you know, it's not as attractive to people, but it is really the response to poor water quality. There's a path forward that isn't maybe as visible, but it's a governance issue. So this has already been mentioned, but I mean, we need to be proactive. You mentioned that, Robert, you know, it's the initial reason that WHO got involved in this whole water safety planning business was because when you had an exceedance, or you had a water quality test that you know had E. coli in it, it was already too late. The outbreak was already there. But there's many reasons why we believe it is cost effective, and you know it is the response in many ways. So. My final slide is about regulation, and again, you know, to make the whole water safety risk management side of things sustainable, you need a couple of things. You need to have obviously a water quality surveillance regime and monitoring, which I think everyone can get behind. But the part that's a little bit more difficult is water safety plan audits. So, you know, that is something where you're essentially looking at local risk assessments, you know, one by one from utilities, and trying to understand whether they have done the risk assessment in a credible way. And if resources allow, a site visit so that you can come and check to see if corrective action's been taken. So I know that when we work with water suppliers and countries, we also need to work with regulators to ensure that everyone's capacity is being built at the same time, because often that is a difficult piece. And we see that when we look at the capacity to audit water safety plans or sanitary inspections, it's far fewer countries are doing this. I think that's all I wanted to say. But again, thanks.
Thank you so much, Bruce. And you see, the policy is being implemented, so that's fantastic. So everybody did a great job keeping to time, but somehow we're over time. So we wanted to have a quick panel discussion. I do want to prioritize, so Robert needs to do double duty with another session. So if anybody has questions for Robert before he leaves us, please, I will take your questions first. But invite anybody up to the mic, please. Ask our panelists anything. Also, those that are online, they're still with us. So if you have any questions from what has been presented, please feel free to come to the mic. Thank you. So maybe we'll take a few questions and then hand it over for response.
So my name is
introduce yourself.
Yes. My name is Gloria from Kenya. I'm a student from Jomo Kenyatta University of Agriculture Technology. And my question is more inclined to packaged drinking water, and specifically bottled drinking water. Bottled drinking water is an integral part of the attainment of SDG 6, majorly because there's a growing reliance of consumption of bottled drinking water as a source of safe drinking water. Now we have regulations and guidelines regarding proper processing and packaging of bottled drinking water. We have monitoring requirements to ensure that the supply of safe of safe bottled drinking water. But with that, you'll still find that they sell of bottled drinking water that does not meet the country's guidelines or the WHO guidelines. So what are the bottlenecks with regard to regulation of that? Thank you.
Right.
I have two questions. So the first slide with 73 countries not reporting, does it mean that the 2.2 billion according to GMP is the entire world without those 72 countries?
Where's Rick?
So the GMP says 2.2 billion people don't have access to safe drinking water, but
Okay.
that only includes the entire world without those 72 countries reporting.
Okay, we'll take the question.
I think that's a question for Rick. But then my other question is, I find it very interesting that we're doing all this testing. At the same time, we are in lack of funds. Overseas development aid will be reducing. There will be less money available to reach SDG 6. Yet I see a lot of funding going into water testing. But we also have the data that 4.4 billion people lack sanitation. Why don't we just assume that all water is dirty unless proven differently, and we empower households to ensure that they can also have safe drinking water at the point of use? Then we can allocate all these testing funds to ensuring that we actually are implementing solutions. How useful is it for households in India to know that their water is dirty if they then have to chop down trees to boil their water, which will create more problems? Okay, I might assume we don't have the answer, but I just want to think around this.
Thank you.
Thank you. Let me start from IRC WASH. One of the great tools, let me put in that way, which the sector hasn't used well to overcome most challenges of water quality, is water safety planning. Not only to overcome water quality challenges, but it is nature to engage most of the stakeholders. My question is, how can we accelerate the uptake of this nice tool by the sector?
Thank you.
Hi, my name is Fernando Benjamin from Wave Solution, working in Uganda as a kind of NGO. In our budget, we struggle to purchase enough water quality testing kit for the field, and there's a requirement there. So I was very interested, I think, by the Dr. Sarah that presented a kind of local water testing kit. So I wonder, is there evidence that it was consistent result matching the kind of high cost water testing kit you find? And at what cost? Maybe was there enough knowledge about that? And then should WHO or global authorities push for the development of such a cheaper, localized testing kit? Thank you.
Interesting. Okay. I'm going to, please stay. Don't go back to your seat. Robert, why don't we take the 4 questions? And Robert, do you want to go first? And I know you have to leave, and then we will continue.
Thank you very much for the question. I want to respond to the bottled water, and I want to be very candid. I know that regulation in my country is still maturing. We had a steep learning curve, but as we were trying now to kind of kickstart and regulation, we asked ourselves, what are our priorities? Within our country context, if we make, for example, something like bottled water as a priority, you enter into another war. This is a commercial war, and you really do not have resources for that. I want to be very candid. We know that we have many manufacturers of bottled water. Half of them, more than half of them, are actually not being monitored in terms of standards. In fact, they're giving us bad water. But we had to, as I said, we had to be very candid. We already had a messed up water supply system from public water supplies, and that is what we prioritize to improve, because many of the things that initial priorities are required to be improved do not require a lot of resources. It's really about building trust with our water service provider, and actually raising in terms of trying to, what can I say, operationalize our values in terms of having that public service ethic, that you're actually serving a product that can impact on the life of people. So how do you change your mindset in terms of how you are going to address the way you are going to process that product? But I agree bottled water is a major issue. But in fact, I had almost constant fights with my board of directors because we differed completely because I was really not in that going to go in that direction because of the resources required and the fights you're going to enter into in terms of public, in terms of the manufacturers. And most of them are people with political connections, and we had a very difficult governance environment. I don't want to call it dysfunctional, but if there are Kenyans in the room, they understand what I mean. So you really had to really ask yourself, where are you going to focus on your priorities? But the point is valid. I think we need to really look at that, but we are actually also want to address the other side of the competition, and that is public water supplies being able to trust, as Bruce was mentioning about trust, their own supply from, their supply from their public water provider. Thank you very much.
Thank you so much. Thank you, Robert. Over to the panel. Do you have an idea of which questions you want to answer? Or I'll just, go down the line.
Sure. Is this turned up? Maybe I can address the question of cost, and two people had cost related questions. So I would counter that water quality testing is actually not so expensive. So hear me out on this one. There was an Acquia study some years back looking at the proportion of overall WASH budgets that are dedicated to water quality testing. And I don't remember the percentage, but it's quite small. And I can say in my experience with these laboratories, I do think the evidence is kind of in that dispersion of the labs. A lot of that uptake across space and over time was really a natural adoption. So the water quality testing, as we arranged it in this kind of contextualized way, fit within budgets and serve dual function, not only for water quality, but as I mentioned, can be linked to health clinics. I didn't mention this, but we also have a series of labs that are linked to schools and science curriculum. So you can sort of snowball water quality testing for multi-purpose. And in terms of the specific costs, I'm happy to share what we experienced, which is the capital cost upfront is around $900. So it is an investment, but it can cover quite some service area. And then the per sample costs from there is somewhere between $1 and $5, depending on the test, the method used, and the number of parameters covered. And then I'm interested in this question, like, should the WHO be promoting such a contextualized approach? I'll just give a short answer to this. My thought is that the method is what ought to be standardized, the metric, how we're reporting the data. But the way in which the data is actually gathered, the laboratory setup, the equipment used, we should really encourage kind of innovation in this space. And we have tools in place like quality control, daily blanks to make sure these processes work, but then also reporting in a standardized way. So that would be my reply to that.
Okay, well, I'll jump into a few. I mean, I think first that you'll notice my colleague Rick escaped because a number of questions pertain to him. But on the JMP methods piece, I mean, yes, there's the data limitation, but the JMP has pretty, I guess, transparent procedures or rules about how they make the estimate. So they need to have above a threshold of 1/3 data availability to be able to make a global estimate. And it's not just they're weighted, by region and normalized and all these other things. So there's a way that you will read in the methods that Rick has explained elegantly from a statistical perspective that will give credibility to that global figure, even though it's representing, the limited number of countries. But yeah, no global estimate is made unless there's 1/3 the population. Where to start? Yeah, just on the water quality, the low cost field tests and whether WHO promotes that. I think it's again, another one for Rick. He'll be doing a session on Friday I believe that where WHO is going to be presenting, I think, some initial data on its assessment of low-cost E. coli test field tests, and so that will be really interesting because you can see sort of what's working and what's not working. But we do think that's a good idea because just using centralized laboratories, has a lot of limitations. So there's a lot of I guess progressions for regulators to try to bring those tests into the fold and trust them. On the issue of accelerating WSPs, I feel like that's kind of been a big piece that I've been thinking about for so long. And I think one of it is that I think there was a perception that WSPs were complicated, that they they're just demanded a lot of planning and a dedicated group, and they were expensive. You generate a risk management plan, and sometimes there's no funding to do the corrective action. So all these issues are kind of constraining things a bit. There does have to be, I think, a regulatory commitment to them for them to be scaled up and sustainable. So there obviously there's a legal thing where you at some point you see, okay, well, we pilot and we sensitize, but at some point it needs to be written into water quality regulations and essentially audited, and that will make it sustainable. And was I going to wade into this question of the question of should we empower households with point of use water treatment when we know water may be of questionable quality? And that's a really good question. I think it's on the one hand, you could say you empower households. On the other hand, you can say you burden households. And I think it's a fair point to make that, I think a lot of us are thinking we need professionalized services and it's worth the long-term investment. But it's also true that there is going to be, long time gaps before, some communities can, rely on, safe water, and they certainly needs to be a solution. And there's already two economies in many places where, they're either treating water at home or buying bottled water and hoping it's safe. So, we acknowledge that. I think it's I don't think it's black and white though. Yeah.
Thank you. And I would like to invite Jafar and Carmen, if you have any reactions to the questions, if you're still with us, please just come in.
No, I don't have any questions.
Okay, thank you. We did have some other questions in the audience. We'll skip the small group unless you really want to meet your neighbor and talk. I'm so sorry, Liz. You have it. Yes, please go ahead. Sorry, Liz.
Yeah, I was just going to comment on some of the packaged water question, because that's actually something that our project is studying in some other contexts. And I think this is a really interesting topic, but what we're finding is the regulatory structure is almost completely separate. It's like a Food and Drug Administration. It's really quite disconnected from the Ministry of Water and the regulators we work at. So I think that's been part of the complexity with trying to push forward that. But I actually, have been thinking about this question of transparency and what do you do when the water utilities are being transparent about challenges with water quality and you have an unregulated packaged water sector that's not being transparent about water quality? And I think that's something that we're diving into to try to figure out what is the impact of having large proportions of the population really drinking sachet or bottled water. So I guess that's sort of a question for Bruce. But
Yeah, no, okay. I won't name the country, but there was some data that haven't been published, but did find testing for lead in water supplies and the bottled water. Yeah, same. I mean, lead contamination in the bottled water. So yeah, it's a big issue. So please, you may now ask your questions.
Thanks. Really enjoyed the talks. And so I wondered, and I thought it was relevant with the Tech Innovation Fair here as well, to ask about any scenarios where we see increased usage of remote sensor data. And there's clearly an uptake and interest in that from water providers to ensure that water is as safe as reasonably practicable. So when you have the water safety plan approach, which is proven and has been used for a long time. If there was any advice on how the kind of analysis you can draw from these remote sensor systems when you have uncertainty in the measurements, which can be harder to verify with respect when you compare it to traditional lab-based measurements. If there was any advice on how someone who's trying to implement these systems or engage with water suppliers can try and encourage these new approaches to fit more within the adopted frameworks, which have been proven in the past. So basically, if there was just any approach or guidelines for how to use analysis which can give you real insight into your systems, but it still feels very separate to the tried and true approaches. So yeah, thanks.
Yeah, Angela Harris from NC State, and thanks. I love the panel discussion. It was a nice array of perspectives on this issue, and actually my comment is quite coordinated with the previous one. I'm curious, like, if we could look into the future a little bit and think about what are the possibilities with like technology development, artificial intelligence, remote sensing. I'm curious if the panel is seeing a scenario where some of these tried and true water quality methods aren't the go-to anymore. And I know that regulatory standards take a long time to change, and these investments in labs and equipment and technologies. And I think about some of these path dependency issues, like, are we kind of making decisions now that are going to kind of limit some of our options in the future? And so, yeah, I'm just kind of, I've tested a lot of water. And so like, I know like E. coli, it has its place, but I'm just kind of curious, like what you see as the future in terms of like, sensors, lots of other ways that we could collect data on water quality that might even be lower cost.
Great question. Okay, we'll take 2 more questions.
Hi there, Clover Demerit from CARE. Just a quick question specifically regarding payments for ecosystem services. The thing about PES that always makes me a little bit anxious is that equity piece that you mentioned. And I always wonder how to kind of, when we're trying to ask upstream land users to adopt more sustainable land use management practices, how to get those incentives right. So I was wondering in your research if you've come across any recommendation or examples to make sure that the incentives for providing these communities actually can help them overcome the startup cost or opportunity cost of adopting different land use management practices, and make sure we're not kind of burdening them with trying to protect the environment or the source water, but making sure it actually is very beneficial for them as well in the long term. Thank you.
Thank you. Over to you.
John Akudago from Habitat for Humanity. My first question goes to the PES presenter. It is very difficult to actually talk about paying for ecosystems from the lower end when the upper stream people want to enjoy what they want to enjoy, especially if you have challenges in the land ownership. So could you share a little bit about to what extent should we be expecting when we have government control over the land versus when the land belongs to individuals? How did you get through such situations? And then the second one is about the relationship between water supply and waste management in developing countries. We all know that waste management is one of a huge area that actually developing countries, governments don't invest in engineered landfills. How do we actually advocate to help bring that solution to water quality problems? Because I think developing countries, engineered landfills are not actually a priority in many places. And so that is actually a big threat to water quality as well. Thank you.
Thank you so much. So let me ask Jafar, would you like to respond? There were some questions around using remote sensing for water quality testing and other parameters, how to fit that within our trusted, regulated frameworks. And then also, use of artificial intelligence and digital. And then Carmen, if you have any reaction to this question, the last question on solid
Yes, yeah,
waste, and there was a solid waste management aspect and considerations for water quality. Jafar, go ahead.
yeah, with respect to the use of technologies, as I told earlier, we are using that, the remote sensing app, especially the GIS based app for, collecting the samples, what we are using. Once the samples is being collected from the field, then the samples will be tested in the laboratories, and once the result is updated in the portal, that will be automatically sent to the end users. And that's why our app is an end-to-end approach towards the sample collection to the dissemination of the results.
Thank you. Carmen, are you there? She may have already left, so
Can you hear me?
yes, now we can hear you.
Okay, okay. I have some issues with my audio. Yeah, so let me also maybe pitch in on this question about water quality without using, testing and perhaps more on the global data that is available and also proxies to help it. So we actually did a study, a water quality diagnostic in Peru about 3 years ago, in where we didn't use data because because we didn't have data available. But what we used, and this was done through Deltares, a consultant firm, we basically use land-based information. We use information in terms of the location of wastewater treatment plant, location of cities, and also other potential polluters. And based also on the hydrological information and water quantity data, we were able to model the specifics of basins and determine hotspots in terms of water quality. And then based on some data available, or physical data available, we're able to also compare it and calibrate it. So just to say, we didn't use it for a regulatory point of view, but definitely something more on the planning approach and identifying hotspots for later plan potential interventions. So maybe that's something to consider too when looking at water quality and how that can integrate with the physical data. So the question on solid waste. So the one thing that we have done at the bank is looking at integrated urban water management, which includes not only, of course, the water supply aspect for drinking water, but also wastewater and solid waste stormwater too, because all those aspects influence and impact a drinking water supply, if we want to call it that way. So I think definitely something that perhaps at the planning stage, we can look at, incorporating solid waste issues in water management plans. So I would say that that's something that perhaps city officials and might want to look at. Usually in the countries that we work on, solid waste is something that the municipalities actually manage. And perhaps the water supply is something that water utilities manage. So sometimes the intersect of communicating between those two agencies is complicated. But within this integrated urban planning is something that we use for more stakeholder analysis and bringing different sectors together to come up with solutions and potential measures to address problems. Thank you.
Thank you, Carmen, and I'm happy to share the water security diagnostic that was mentioned for Peru if you're interested. Over to our panel. There are a few questions, but I will ask you to keep them quite short because we're running out of time.
Yeah, I guess I can address the questions, particularly on PES. And I think that question about avoiding burdening the upstream community is really the critical one. And that is where a lot of these programs fall apart if you don't get those incentives right. It's not the most innovative answer in the world, but the community consultation step is really the important part in addressing that. In the case of Peru, for example, there actually has to be an agreement signed between the utility and the upstream community documenting what is the intervention going to be? What is the payment going to be? And that's an important step, and it takes a long time. It's one of those other reasons why you don't actually see source water protection happening as fast as some might like, is that you have to take the time for that step. And I think to get to the other question, a challenge with that can be in places where not everyone upstream has land tenure. Because typically to get those payments, you're going to have some sort of official land tenure. And if you try to prevent people from using land they've been using without the incentive structure, it really just doesn't happen. But when you get it right, what we've seen in some of our case studies is that it can actually improve relationships between the utility and the upstream community, because that's where the water intake points are anyways. So in the case of Peru, there were examples of utility staff having encountered kind of community resistance to them coming in to do maintenance work. And once the PES system was in place, they actually didn't have that problem anymore. So it was kind of a very unexpected benefit to the utility.
And okay, so maybe I can comment on Angela's question. I love this brainstorming of what is coming next. From my perspective, so again, getting back to the cost, I think the data needs for making good decisions can actually be a bit less than you might imagine. I personally, I don't see a huge role for ever more data and remote sensing. For what we need to do is really understand which systems are at risk and which control measures should be implemented. I think Saskia today presented this morning that as little as 3 microbial samples per year can give you a fairly good, reasonable sense for which systems across, a population require intervention. But what I will say, and what's exciting to me, is many water supply systems like the ones I showed are untreated. I would even say maybe most. And there's a lot of innovation in the space of remote sensing and machine learning methods for automating dosing of, say, chlorine technologies that are a bit difficult to reach. But if you can add, sensors are getting cheaper, the management of these treatment units can actually become quite easy. It's relatively affordable. So I'm working on a few projects exactly in this direction. And it's for the first time, we're thinking about these machine learning techniques for improving dosing for rural contexts, which wasn't the case, a few years ago. So who knows what we'll see there.
Last words, Bruce.
Oh, I was going to try to get out of it. Yeah, no, the future thing is interesting. I mean, in some ways, I'm just absolutely sort of flabbergasted on what's happening with wastewater and environmental surveillance right now. It's incredible. I don't know if that will, we'll start monitoring source water and using molecular methods. And I don't know. So I have that on the one side, where I still think when people think about that, it's the use cases that are probably not the use cases, but you have, well, I guess there's a lot of people is that a party trick, or is it going to usefully inform public health? And similarly, some of these, I haven't been keeping up with the literature, but some of these things, are they, we're already having trouble, using the data we have on basic things like turbidity and chlorine residual. And then, so, how far do we want to push on? So there's a little conservative part of me that is not the right person to answer the question, because I think it is a really exciting domain and I think we probably can solve a lot, but my brain isn't actually, I'm like the older generation now. So then there's younger people that probably wouldn't have the answer. So that's why I was going to get out of it, Claire. Completely unsatisfying.
Thank you. And we have last words from Aidan Cronin. Do you want to? So Aidan is a senior advisor at WASH Results and Resources at UNICEF. Please.
Thanks, Claire. I thought it was a duet, so that's why I was. This was a great session. I think really fitting in the ethos of the conference across science, policy, and practice. And I thought maybe that's a good way to structure some reflections on it. And I was brought back to actually my own experience in water quality monitoring at scale from Indonesia, where we supported the government to integrate a water quality testing component into a national household survey. And we did it in one province, so quite large scale to kick off, and the results really flabbergasted the government because, of course, you know, what you look for is what you find, and we went from 80% improved drinking water to 8% safe drinking water. So it's a shock. And if you're sitting in the government, and we've I think very rightly heard in the plenary sessions and in other sessions so far that it does come back to the government. I mean, it's the duty bearer. You know, how do you take those tough decisions, and where do you put those scarce resources? And maybe that was the only point I disagreed with the panel a little bit on. Using you do need data and evidence for the bigger level prioritization, system strengthening, but I know that we weren't talking at that scale. We were talking at a little bit of a different scale. But I think what we did recap on is the huge challenges: industrialization, urbanization, population growth, aging infrastructure, and and climate. And we didn't touch so much on but that is coming, and I think that is something that we can use as a lever for water quality, and leveraging the importance of water quality. So the climate story isn't only about water resources, it's also about water quality. So maybe this is a book for us to move forward with. I really liked all the great examples, very practical, very action orientated. Right from upstream to monitoring and intervention. But it's clear that we need to have a comprehensive action plan right across the spectrum, from the catchment level down to the user, and to communicate those results, well, as Bruce touched on. So I think my key takeaway from the session is that, there's great examples of innovation, technology. We need to pull that story together more to optimize kind of that resource allocation, to really, support both at the local level for action, for immediate action, where those risks are being identified through water safety planning, etc. But then also to bring that up to the next level, which is about, building those systems to have impact at scale. And the examples from Nepal and India were excellent, because you are showing that it is possible at scale, and that you're using technology to do that. So maybe how we, maybe these are questions for some of the researchers in the room. How could we use that technology and those innovative elements to really bring together that local, to merge those local level actions and the larger system strengthening, within a kind of a structured framework that, of course, varies across different contexts. So just some kind of wild ideas, but I really enjoyed the session. Thank you so much.
Thank you so much, Aidan, and thank you to all of our speakers. Really excellent work, and thanks for all of your participation, and also to all of you. Thank you. You're free to go.